Good morning. Myself Manoj, Assistant Professor, EC Department, Chebroolu Engineering College, Chebroolu. And today's topic is transistors. Introduction to transistors. Okay. So, what is a transistor? And why do we need a transistors? First of all, what are the use of transistors? Suppose you have an FM receiver which grabs the signal you want. The received signal will obviously be weak due to disturbances it would face during its journey from transmitter. Okay, suppose that there is a transmitter and a receiver, and receiver receiving signal and transmitter is sending the signal. So in the meanwhile, what is happening is the signal may be weak due to disturbances, may become weak due to disturbances it would face during its journey to receiver. Now, if the signal is read as it is, you can't get a fair output. Hence, we need to amplify the input signal. Amplification means just increasing the signal strength. So, to increase the signal strength, I need some amplification circuits. So, amplification is needed wherever the signal strength has to be increased, and this is done by transistor. So a transistor can also act as a switch to choose between available options. It regulates the incoming current and voltage of the signals. Okay, so a transistor can amplify the input signal, can act as a switch, and it also regulates the incoming current and voltage of the signals. Okay, so now what is transistor? A transistor is a three-terminal semiconductor device. Okay, it is a three-terminal semiconductor device that amplifies or switches the flow of current. So a transistor is three-terminal semiconductor device that amplifies the electronic signals such as radio and television signals. Before the transistors came into existence, vacuum tubes were used to amplify the electronic signals, but nowadays vacuum tubes are replaced by transistors because they have various advantages for vacuum tubes. So, what are the advantages of transistors when compared to vacuum tubes then? Transistors offer low power consumption and the cost is low because fabrication cost is very low. They have small in size, higher efficiency, low voltage is needed to operate a transistor. It is the main concept. Low voltage is needed to operate the transistors. High physical ruggedness when compared to vacuum tubes, and they produce less heat when compared to vacuum tubes. And transistors are very lighter than vacuum tubes. So, and there are many advantages such as they have high voltage gain, lower supply voltage is sufficient, as I said, more suitable for low power applications, very less weight, small in size, mechanically stronger than vacuum tubes, and no external heating is required like in vacuum tubes. And there are very suitable to integrate circuits with resistors and diodes to produce ICs. Okay, so these are all the advantages: low power consumption, low cost, small size, higher efficiency, low voltage needed to operate transistors, and high physical ruggedness when compared to vacuum tubes, and they produce very less heat when compared to vacuum tubes, and they are very light in weight. Okay, and high voltage gain, low supply voltage is sufficient to operate transistor, and most suitable for low power applications, smaller and lighter in weight, mechanically stronger, no external heating is required like vacuum tubes, very suitable for integrated circuits. So, in the view of all these advantages, we are moving on to transistors. Okay, so now how many transistors are there? What are the classification of transistors? Basically, transistors are divided into uni-junction transistor, which is not shown here, uni-junction transistor, bipolar junction transistor, and field effect transistors. Okay, so UJT means uni-junction transistor, BJT means bipolar junction transistor, and FET, field effect transistor. Again, BJT is divided into NPN and PNP transistors depending upon construction. Okay, depending on construction, NPN and PNP transistors. And FETs are classified as junction field effect transistors and metal oxide semiconductor field effect transistor, MOSFET. Okay, there are some other classifications also, like MESFET, metal semiconductor field effect transistor, and IGFET, insulated gate field effect transistors. I have not shown this in this diagram, right? So again, FET is divided into, JFET is divided into N channel JFET and P channel JFET, right? And MOSFET is classified as depletion mode MOSFET and enhancement mode MOSFET. Again, depending upon type of channel which you are using in depletion and enhancement modes, again depletion mode MOSFET is classified as N channel depletion mode MOSFET and P channel depletion mode MOSFET. Likewise, enhancement mode MOSFET is classified according to the type of channel, such as N channel enhancement mode MOSFET and P channel enhancement mode MOSFET, right? And in this course we will study about all these transistor classifications. Okay, and now what is a BJT now? So my main classification is BJT, FET. Of course, this UJT is also there, and I am not covering that topic in this unit. Okay, so what is BJT? As the name indicates, BJT means bipolar junction transistor. Bipolar junction transistor. So why the name bipolar? Okay, so a bipolar junction transistor, or BJT, is a three-terminal semiconductor electronic device that amplifies the flow of current. Transistors are used to amplify the current or voltage. Okay, so BJT is a three-terminal electronic device that amplifies flow of current. And make a note that BJT in this classification is a current control device, whereas FET is a voltage control device. Okay, BJT is a current control device. Okay, so it is a current control device. In a bipolar junction transistor, total electric current is due to both majority and minority charge carriers, means electrons and holes. So both electrons and holes takes part in conduction. Both the polarities, positive polarity holes and negative polarity electrons, both takes part in the conduction of current. So both polarities of charge carriers here are available for the contribution of total current. That's why the name bipolar transistor, junction transistor. Why the name junction is used here? Means in this transistor, in this BJT, we have two junctions. So that's why the name bipolar junction, and it is a transistor which can amplify the input signal. Okay, so that's why the name BJT, bipolar junction transistor, right? So a transistor is a three-terminal solid-state device which is formed by connecting two diodes back to back. Okay, two diodes back to back. I can say like this. Okay, a transistor is a three-terminal semiconductor device, solid state device, which is formed by connecting two diodes back to back. Means suppose that if I take anode and cathode of a diode, PN diode, right, and I will take another PN diode, right, and then if I connect them like uh, the cathode of one diode is connected to cathode of another diode. So what will happen? Anode of one diode, both cathodes are connected together, and anode of second diode is open like this. So what will happen? It will become a transistor, theoretically, not practically. Okay, if I connect two PN junction transistors back to back or front to front, then practically it doesn't act as a transistor. Why? Because there are so many other reasons we'll discuss in few minutes. So theoretically we can say that a transistor is a device formed by connecting two PN junctions back to back, theoretically, right? The three terminals are drawn out of these three semiconductor materials present in it. This type of connection offers two types of transistors. They are PNP and NPN. In a PNP transistor, a N-type semiconductor substrate is sandwiched between two P-type semiconductor materials. It will form a PNP transistor. And likewise, a P-type semiconductor can be sandwiched between two N-type semiconductors such that it will become NPN transistor. Okay, so a bipolar junction transistors are classified into two types based upon the construction. There are NPN and PNP, right? So both NPN and PNP transistors consist of three terminals: emitter, base and collector, right? So this is the schematic and symbols of NPN and PNP transistors, right? So let us take a schematic which is shown below of your screen, NPN and PNP, right? So here a p-type semiconductor substrate is sandwiched between two n-type materials forming three terminals: emitter, base, collector, and it is called NPN transistor. Okay, and similarly, if a n-type semiconductor is sandwiched between two p-type semiconductor substrates, then also it will form three terminals transistor, and it is PNP type. Okay, and the symbols are shown on the top of the screen for NPN and PNP transistors. For NPN and PNP transistors, the arrow mark on emitter terminal, represents the type of transistor, NPN or PNP. Okay, and it represents the flow of current into or out of the transistor. Okay, for a PNP transistor, current flows from emitter and divides outside to base and collector. Okay, whereas for NPN transistor, current flows from base to collector, from base and collector, and they combinedly come outside through emitter of transistor. Okay, so it is NPN transistor. So there is one shortcut to remember whether the transistor is PNP or NPN. Okay, for PNP transistor, the arrow mark is pointed inside. PNP, pointed in. Okay. Excuse me. So for a PNP transistor, the arrow mark is pointed inside, pointed in, PNP. So the arrow mark is towards base, towards inside of transistor. Okay. Always arrow mark must be represented on the emitter terminal only. Okay, and for NPN transistor, the arrow mark is towards outside the transistor. Okay, NPN not pointed in means it is pointed outside. Okay, so just as I said here, now NPN and PNP transistors are two types of transistors we have in BJT, bipolar junction transistors. Okay, here the p-type semiconductor is sandwiched between two n-type semiconductors to become NPN, and if n-type semiconductor substrate is sandwiched between two p-type semiconductors to become PNP transistors, and it forms the terminals emitter, base, collector. Okay, irrespective of type of transistor, it may be NPN or PNP, emitter width is high. Okay, emitter width must be high and base width must be very less. The base width must be very less, and the width of collector must be greater than the width of emitter. Okay, make a note. For NPN and PNP transistors, for any transistor, for any BJT transistor, bipolar junction transistor, emitter width must be higher and base width must be less, and the width of collector must be greater than the width of emitter region. Okay, and the most important second point to remember is, irrespective of type of transistor, whether it may be NPN or PNP in BJT, emitter is highly doped. Emitter is always highly doped. Okay, and base must be lightly doped. Base must be lightly doped, and collector must be moderately doped. Okay, emitter must be highly doped, base must be lightly doped, and collector must be moderately doped. Means the doping concentration in collector region is nearly equal to doping concentration of emitter region, but a bit less. Okay, so it is the doping concentration and widths. We have to construct transistor like this, BJT like this. Okay, so what are the applications of transistors now? So there are various applications of bipolar junction transistors, and they include, the main application is amplifier. Okay, the main application of transistor is an amplifier. So it can be used in audio amplifiers, and it is also used in circuits of radio transmitters, computers, mobile phones, televisions, oscillator circuits, and they also use as a switch in digital circuits. Okay, these all are applications of transistors, right? And now my question is, as I said earlier, if two diodes connected back to back or front to front, we may assume it as a transistor. Okay, but practically it's not feasible. Feasible. Why? Because there are so many reasons. Okay, so if I connect a diode back to back, it will become PNP transistor. If I connect two diodes front to front, it will become NPN transistor. Okay, so theoretically we can say that it acts as a transistor, but practically it doesn't act as a transistor. Why? Because in actual transistor, the base width is high and emitter width is high, the base width is less, and collector width must be greater than the width of emitter region. So if I connect transistor back to back or front to front, it will not satisfy these conditions. Okay. And second thing is, if I connect transistor back to back or front to front, it will not act as a transistor due to second reason. What the reason is, in emitter region, I will dope emitter heavily. Okay. So doping concentration in emitter region is very high, and doping concentration in base is very less, and doping concentration in collector region is moderate. Means it's also high, but when compared to emitter, a bit less. So what is by doping actually? Doping is nothing but adding an impurity to a pure semiconductor to increase the conductivity. Doping is an act. Doping is an act of increasing the conductivity of a semiconductor material by adding impurities. Okay. So the doping concentrations varies with emitter, base and collector regions. So if I connect transistor back to back or front to front, due to the second reason, it will not act as a transistor, practical transistor. Okay. So the transistor can be operated in three modes. Now coming to modes of operation. We are now coming to modes of operation. A transistor can be operated into three modes. First one is cutoff, second one is saturation mode, and third one is active mode. Active mode. Okay, these all are three modes of operations. There is fourth mode called reverse active mode, and we don't use it. We don't use it much more. Okay, so a transistor can be operated in three modes. These are all modes of operations, right? Cutoff mode, saturation mode, and active mode of operation, right? So in order to operate transistor in one of these three modes, what we have to do, we have to give a proper biasing, proper DC supply, proper DC biasing to the circuit. Okay, based upon the polarity of applied voltage, transistor can be operated in any of these three modes. Okay, it will act in any of the three modes, right? So we have to give proper biasing. So applying proper operating voltages and choosing proper circuit components in order to make currents and proper currents to flow in the circuit is called biasing of transistor. Okay, applying proper voltage to a transistor, to a circuit, right, and choosing proper components in order to make the currents flow properly in the circuit, it's called biasing. Okay, so we have to give biasing to the transistor, right? So depending on this biasing, there are three modes of operation. One cutoff mode, second one is saturation mode, and third one is active mode. Of these three modes, in order to make transistor to work as an amplifier, we will choose active mode. So let us talk about these three modes of operations now, right? So first one is cutoff mode, right? So for this, let us move on to the circuit schematic diagram first, right? The figure which is at the bottom of your screen is a schematic, right? So NPN and PNP, right? So here there are junctions in this transistor. Okay, the first junction is between emitter and base. The second junction is between base and collector. So the first junction, which is between emitter and base, it is called input junction. Okay, it is called input junction, right? So So the junction present between emitter and base, this junction I call it junction J1 or junction JE I call it. Okay, I call it junction JE. Okay, JE means input junction. JE means input junction which is present between emitter and base. This junction I call junction JE. Okay, likewise there is another junction between base and collector. I call this junction which is present here. Okay, this junction. This junction. I call it junction JC. It may be for NPN or PNP transistor. The junction between emitter and base is called junction JE. It is called input junction. Likewise, the junction between base and collector, this junction is called output junction, JC. Okay. So in order to make transistor work in cutoff mode. Okay, cutoff mode. So what we have to do? Junction J1 means input junction must be always forward biased. Cutoff mode kada talking about, right. So in cutoff mode, to make resistor to work in cutoff mode, both junctions J1 and J2, must be reverse biased. Both junctions, junction J1 and junction J2, must be reverse biased to make transistor work in cutoff mode. Okay. So here I am taking example of NPN transistor. So that when this become reverse biased, okay, if I connect positive terminal of battery or voltage source to N-type semiconductor region and negative terminal of battery to P-type semiconductor region, it will form reverse bias. So here the voltage source VBE means it's the voltage applied between base and emitter. It is the voltage applied between base and emitter. That's why I call it voltage VBE. Okay, here the positive terminal of voltage source VBE is connected to N-type emitter region, and negative terminal of battery is connected to P-type base. Okay, it forms reverse bias. Likewise, junction J2 is also reverse biased. Means VBC is the voltage given between collector and base, right? If the positive terminal of battery or voltage source is connected to collector, okay, and if negative terminal of battery is connected to P-type, it will form reverse bias. Okay, so that if both junctions are reverse biased, then it is called cutoff mode. Then this is called cutoff mode of operation, right? Since both junctions are reverse biased, as we know that in reverse bias, no currents will practically flow in the transistor. Okay, therefore in reverse bias condition, no current flows to the device. So transistor is said to be in off state. Okay, and it acts like a open switch. The cutoff mode of operation of a transistor is used in switching operation for switch off application. Not for on application, off application. So cutoff mode is equal to open circuited switch. Okay, and now let us move on to saturation mode. In saturation mode, what we'll do? Both junctions are forward biased. If both input and output junctions are forward biased, then it is called saturation mode of operation. Okay, it is called saturation mode of operation. To make junction J1 forward bias, what I have to do? The negative terminal of voltage source VB is connected to N-type emitter region and positive terminal of voltage source connected to P-type base region to make junction J1 forward bias. Likewise, junction J2 must also be forward biased. Means when the negative terminal of battery is connected to N-type collector region and positive terminal of voltage source VBC is connected to base region, which is P-type, then it will form forward bias. It will form junction J2 to be forward biased. Okay, junction J1 is also called junction JE. Alage junction J2 is also called junction JC. Okay, when the transistor is operated in saturation mode, what will happen? As I said now, I can assume transistor as two diodes connected back to back. This is one diode PN and this is another diode. Okay, so as I said now, both junctions J1 and J2 are forward biased here. So what will happen? More current will flow in the circuit. Current flows the device. Hence, electric current will flow in the transistor. Okay. So, in saturation mode, the charge carriers, electrons, flows from emitter to base as well as from collector to base. So, the electrons which are majority charge carriers in N-type region of emitter are repelled due to negative polarity here. So, electrons will move towards base here. Likewise, so what will happen? The current direction is opposite to flow of electrons. Likewise, here junction JC means junction J2 is also forward biased here, because here N-type region, which is in collector region, electrons are here majority charge carriers. These electrons are repelled due to negative terminal of VBC. So what will happen? Electrons will move towards the base region. Likewise, what will happen? A large amount of current can be flown to the transistor. Okay, to the transistor. So we can say that transistor is now operated as on switch. Okay, So here maximum current will flow to the circuit. Okay, that's why I can assume transistor now will act as short circuited switch. Okay, means on state. So from this discussion we have till now, we can say that operating of transistor in saturation cutoff region, we can use transistor as an on-off switch. In saturation mode, it acts as on switch. In cutoff mode, it acts as off switch. Okay, and last one is active mode of operation. In this mode of operation, what we have to do? The input junction is forward biased. Input junction is forward biased and output junction must be reverse biased. Okay, input junction is forward biased and output junction must be reverse biased. So, irrespective of type of transistor, whether it may be NPN or PNP, whether it may be NPN or PNP, input junction is forward biased and output junction is reverse biased in active mode. Okay. So we can assume it as to, if I assume it as two PN diodes, this is one PN diode, this is, sorry, this is one PN diode, and this is another PN diode. This is another PN diode. Okay. So here one diode will be in forward biased and other diode will be in reverse bias. Therefore, the active mode of operation is used for amplification of current. Make a note that if I make input junction forward bias and output junction reverse bias, then transistor works in active mode. In this mode only, transistor acts as an amplifier. Transistor will act as an amplifier. In saturation cutoff modes, it acts as a on switch or off switch. So from the above discussion, we can say that transistor works as an on-off switch in saturation and cutoff modes, whereas it works as an amplifier in active mode. Okay. This is all for this class. See you tomorrow.